Hello, Ray. Good to see you again.
Hi, Richard. Nice to get together again. It's been slightly longer this time.
It has been a while, but probably
Lives get
good to
busy.
give everybody a break. We've been laying it on them pretty thick.
Yeah.
So excited to get into this one. And I think you have a theme today, right?
Yeah. Well, I think I called it subtle energies. It's more about how some other aspects of what we see can fit into this model when we start to understand that we're dividing up space and time with the harmonics theory. And when we look at space divided by time, it gives you velocity. And it turns out, waves of different velocities, and that they all shown the same structure of the harmonics theory.
Mm-hmm.
So,
and you have a name for it that you called universal wide web or something?
Oh,
like
yeah,
that?
the universe wide web. Yeah,
wide web.
It's worth mentioning at this point, I think, a little bit of what drove me into that was when I first started putting stuff on Usenet. This is before the World Wide Web had existed. I was putting stuff about physics, astronomy, I think a bit of geology and a couple other things. And I started getting email from people in the alternative health field and comments on the things I put up. And I thought, that's funny because I didn't mention anything about that stuff. But these people were seeing things that I hadn't seen yet in it, which were the connections and the structure in the human body and in the subtle waves and things like that. And so they gave me a little push in that direction, I think, which was good. I think all scientists should listen to these people in alternative health and the people who, which might be regarded as a little bit fluffy, they're the seers. And they aren't scientifically precise, but they're seeing things that others don't. And the scientists come along later on and nail it all down, But that isn't necessarily improvement. You've got to be careful you don't lose the message. And
The scientists come in, nail it all down, and take all the credit.
Yeah, that's right. Yeah.
And dismiss all of the charlatans that came before them.
That's right. I've always had one foot in each camp, but I probably had my foot in the scientific camp a bit more heavy than in the other one. Yeah.
I like to think of the foundation as being a balanced organization. Yes. All right, well, let's get into the slides that you were going to talk about today. Great. So
this is the calculation of how strong the harmonics should be relative to the general trend for all the harmonics out to about 10 to the 40. Now, I did them a bit further than that, but the thing that we see are, I've labeled peaks 1, 2, 3, 4, 5, 6, 7, 8. They're not perfectly regular. There's a bit of variation, but there's the spacing to the first one and second one are typical of the other spacings, but sometimes are a bit smaller and a bit larger. So this is the structure of the universe.
Normally I think of 10 to the 40, right, as being a big number, and 10 to the 0 as being a small number. But
that's right.
What are these? But isn't this like the large structure over here and the small structure?
Yes, that's right. Yes, yeah.
So why
it's the harmonic number, which is the division of the universe. Yeah.
Okay. All right. So just to remind people, refresh everyone how you predicted, how you created this structure.
Yep.
Going back to, our first conversation. And I know I keep coming back to this, but I think it's important. It's such an anchoring thing that everybody really needs to have their mind wrapped around, right? So, you're taking the integers basically and looking at all the different ways that you can create that integer, right? So
yeah, that's right. So they are the harmonic numbers. Well, across the top of the harmonic,
and then adding them up
is the harmonics as well. And it's just simply calculating how many ways can we make each harmonic according to the axiom, which says number one harmonic makes all these other ones, and each of these does the same. So then we do the same with 2, the same with 3, same with 4. And we see that some of them are already made several ways. So when we feed it back in, so 4 was made in 2 ways.
4 was made in 2 ways.
Make 8, it contributes 2 ways to 8 and 2 ways to 12.
Right.
Because it was 4 and 2 times 2.
And so when you add these up vertically, you get the different ways.
You get how many ways each harmonic is made at the bottom.
And then you get this structure, right?
That's right. Yeah. And the number of ways
can be made,
obviously going up as we go to higher numbers.
Yep.
But counteracting that, is the fact that as you go to higher order harmonics, they get weaker and weaker. So we've got to factor that in as well. And when we do that, we get something like this.
This is where you've essentially, would you call this normalization?
Yeah, that would be a good term for it. Yep.
Okay.
And that's when we start to look at that, we discover, hey, there's a musical scale.
Right. And then we can go out to, 10 to the 6th here, and then all the way out to
10 to the 50.
10 to the 50. And this is all just mathematics. This is all just calculating.
That's one simple thing we did in the first one. It's just doing that more and more and more. But I had to work out a few mathematical tricks to get it that far, because the number of ways that the last ones there can be summed up are extremely large numbers.
Right. And so in doing that, those calculations,
that's what comes out.
This is the structure, kind of a zigzag line of overlaid on those peaks, which is, and then you find that this structure is reflective in the actual measured, observables in our universe and our bodies.
So those ratios are, those peaks are a typical ratio of about the 34560 in the first one is a typical ratio for the rest of them. Yeah.
Mm-hmm. Okay. So with that, again, as the mathematics, right? And we get into the actual observations. So tell us what we're looking at.
So again, starting from the larger scale, the Hubble scale, these are the things that we actually observe. The biggest things, the most dominant things after the Hubble scale are galaxies. Now, we'll get a little bit more things in there later. Then the stars, then the planets, then moons. There's no obvious things on the next two. Then cells, atoms, and nucleons, protons, neutrons. So that's the I've marked those each at the correct ratio for those things, bearing in mind that some of them have more than one. So with planets, in our solar system, we have the gas giants and the terrestrials, and there's a different scale to each. So I've marked both of them there. Mm-hmm. With the galaxies, we have the large spiral galaxies and the small irregular galaxies. And that one, for example, the Milky Way has the two Magellanic Clouds floating around it. And when we look at Andromeda Galaxy, it's got two little hangers on as well. And they're at about 1/12 scale, the distances there.
So
I think I might have mentioned before, but it bears mentioning again. Someone said to me, yes, they said, those are water molecules, H2O. And they are. You've got the big thing and the two little ones hanging on. So we can have a chemistry of galaxies and no doubt at other levels as well.
So along the axis here, you've got these regularly spaced intervals, which you say have a ratio. So if you divide, the bigger one by the next one down, they have a ratio of 34,560. And where did that number come from?
That number is the first peak in the calculations, and it's also typical of the distance between the peaks and that.
So we don't actually expect them to all. One, is it in here, right here?
Yeah, that's right.
And this is the biggest peak on this first set of calculations.
Yes, that one and 17280 are pretty similar, actually. Yeah.
Okay, so those are the regularly spaced intervals. Kind of, again, this is theory, and then you have the locations of the observables, and noting how they kind of line up pretty closely. Like the gas giants are pretty close to this one. The moons are pretty close to this one. Cells, atoms. So they're remarkably close to the theoretic structure.
And we don't expect them to be exactly the same because they aren't actually perfectly regular. Now, I didn't use those calculated ones in this because originally I thought the Hubble scale is the biggest scale. It's a natural assumption because that's what the Big Bang people tell us. But in fact, later on when I did the calculation, I discovered actually it's not the biggest scale. It's a further down one. So here I've just shown a representative spacing.
So we can, you're making a prediction that there's something bigger than the Hubble scale that will be found.
And I see that they're getting better and better at observing neutrinos. And I've mentioned some time back, the way to go beyond the Hubble scale is make a neutrino telescope. Now, effectively, they're making such big things underground that can detect neutrinos now that they are starting to make neutrino telescopes and work out where they come from. So at some stage when they get them even better, we'll be able to observe the universe with neutrinos who can travel much further than that.
All right. Anything else on this slide that we haven't covered?
No, that's it.
Okay, moving on.
So this is just improving that one I did originally of the galaxy and the star and the planet, showing the fact that there are multiple peaks at each one. So, for example, there are galactic superclusters. And with galaxies, there's irregular galaxies, the little hanger-on ones, and there's also globular clusters. They're distinct things floating around. And then as well as stars, there are giant stars that have a bigger spacing. And as well as the giant planets, there are the terrestrial planets. So there's two peaks. And there's a little bit of that happening in the moons as well. And at the scale of cells, there's bacteria and virus. At the scale of an atom, the electrons give a slightly smaller scale than the atom. Now, in standard theory, they talk about the electrons and the nucleons, but they don't really look at what the function of an atom is. But when they work out the masses of an atom, it doesn't equal the sum of the nucleons and the electrons. And the reason is there's another wave there, which is the atomic wave, in my opinion. In fact, we know that's there because when you look at a crystal, you get these very regular atomic spacings. So there's clearly a wave running through it that's holding them all together. That's my way of looking at it anyway.
And again, that is showing the structure in how these have kind of multiple peaks.
Yes, that's right. Yeah.
One, two, three.
Yeah, nearly all of them have a secondary peak.
All of them have a
secondary peaks are very commonly at a ratio of 12 to the original, but they may be at 24 or they may be at 20 or 28 or other numbers around that range.
Right. And just going back again here, these are the ratios up here between.
Yeah, so you can work out the ratios there. So for example, that number 2 peak, you can go 2, 3, 2 and get from one to the next and so on.
Right. 2 times 3 times 2.
Yeah.
2, 2, 2. And then there's a big one here, 11, for example.
Yeah.
That's
when you get those big primes come in, the big primes come in usually in the dips, right? And the big peaks happen between the big primes, between fives, in fact.
Okay. Very good. All right. So I think we can now go to this one. Yes?
Yeah. So the important thing is to remember that we're both, these waves that I say are happening, these large scale waves in the universe and down to small scales, they are both dividing up time and space. If we think of a guitar string, when we pluck it, if we put our finger on halfway and pluck the second harmonic, it divides time into half size pieces, but divides the space into half as well. It's doing both at once. So that we often do, if we do periods, we're dividing up time. If we do frequency, we're multiplying, whichever way you like to look at it. But I'm showing there dividing in half, a quarter, and 12th, which are the common ones. A little sketch just to show that. Just remember that time and space are doing that.
I think the guitar string is a great example because, you are dividing it in half. And it's a physical thing, and then it's twice as fast.
Yeah, and some people will like a violin string instead, but it works the same.
Yeah, works the same. All right.
Not to forget the celloists. Yeah. Now we talked. Most of the stuff we talked about up till now has been speed of light phenomenon, but in this case here, I started looking at the speed of other types of waves. So we have sound waves, and this is an analysis of 48 different solids. And showing the speed of sound in them using the Kotoff's method again. So it's looking for values.
How fast sound moves through each of these solids.
These solids, yeah. Okay. Yeah. So if you get a hunk of steel or something, or get a big gong made of brass and hit it, and sound travels very fast through it, but nothing like as fast as light. And so this is using Kotoff's method again. It's looking for values that all the other ones tend to be multiples or fractions of. And it comes out with a 6.42 kilometers per second. And I'll call that a typical speed of sound phenomenon. And there are other ones that are very close to half that, and also very close to 1/12 of that. And those ratios of 2 and 12 are the things we commonly see in the harmonics theory. And if we look at some of those lesser peaks, we can find a ratio of 3, 2, 2, 3. We find that whole normal structure going on there.
Wow.
I have done the same thing with heat. I haven't shown that here. The heat one is not quite as obvious, and people don't usually talk about the speed of heat, but it does have a speed. Yeah.
Okay.
So why is there a speed of sound? And so this is my thoughts on it. This may not be the best way. There's possibly other ways, but it gives me one way of getting to it, and that is that at the top left I've shown there what's supposed to be 4 nuclei all banging against each other, and you bang the first one, and a ripple effect will go through them all, right?
Okay.
It's like Newton's balls, except this is with nucleus. And so in that case, the speed of the wave in those nuclei will be the speed of sound, because they're interacting on the the speed of light, because they're acting on the strong force. Below there, I've put 4 atoms. It's got I'm showing the atomic size, and in the center, I'm showing the nuclear size. But although the nucleus is vastly smaller, it's vastly more energetic and more massive than the atom itself. So when we put a force onto an atom to make it bump the next atom, it's like having a big ball of sponge rubber and having a very dense piece of steel in the middle. And so when you push them against each other now, the sponginess means it's much slower transferring the energy, because the momentum of the piece of steel keeps on moving when they collide and pushes them hard against each other before it springs off. And then it's slow to transfer that to the next one and so on. When I say slow, if we divide 3.4560 into the speed of light, we get about 9 kilometers per second, of the same order as what we were getting with those the sound propagation one. It won't be exactly the same, because it depends how many particles are in the nucleus for different substances, and there'll be even different nuclei in chemical compounds. So, but it's of the right order of magnitude. And so this is the transfer of...
Meaning like 6.42 versus 9.
Yes.
So it's not 100. It's, it's within the neighborhood.
Yeah, because we're going from 300,000 kilometers per second for the speed of light down to here. So it's a neighbor.
Right.
So that's my explanation for that, of why that's why there is this difference between the speed of light and the speed of sound. But it doesn't stop there. We can define a speed of heat. The normal way that heat is measured is not defined as a speed. It's a transfer rate depending on the temperature difference and stuff. But you can turn it to exactly the same wave equations we have for light and sound, and you can determine a speed of heat. And when you do that, I've got the velocity in centimeters per second there. Light is up there, sound, and I've put heat. Now, nervous impulses, there are multiple different types of nerve impulses. One of the most important ones that shows up in a lot of the phenomenon going on in the human body that we'll do after this is about 1 meter per second. So it's a lot slower than the sound, which was 6 point something kilometers per second.
Right.
Sorry, you Americans, you're going to have to learn to use metric system. This is too difficult in imperial units.
Wait a minute. I thought we decided the imperial system actually was more consistent with harmonics in an earlier episode.
It is, but it's not so consistent with doing calculations.
All right. It's not as easy. It's not as convenient.
No,
it is structurally.
Yeah. It's interesting. It's interesting that we have both in the world, isn't it?
It is.
And then, so these ratios, we've got about 3, 4, 5, 6, 0 ratios between each of these, but we can carry on. Ocean currents and continental drift. Continental drift is of the order of a couple of centimeters per year, right? Ocean currents, we can see those. And these other ones, nervous impulse happen quite fast. Sound happens extremely fast. You bang the end of your table, the other side seems to move straight away, but in actual fact, a wave went through there.
So when you divide light by 34,560, you get to roughly the speed of sound. When you divide sound by the speed of sound by 34,560, you get roughly to the speed of heat or nerves, nerve impulses, etc.
and then ocean currents, and then continental drift. Now, it then tends to strike you that when we look at those, the bottom one, continents, Earth, ocean currents are water, heat and earth, not so obviously air, but and sound, fire, but we've got the classical elements there, and light is ether. So we've got these 5 things there. Well, to show those ratios. Could there be more below there? It's conceivable. They would be a bit slow for us to notice. But there may be other slower processes. It's hard to envision them because the solid Earth is the most dense thing we've got there. Could there be more things above there? Now, I'm a very funny fellow, like to be obtuse in some things. I disagree with the physicists when they say that when you do certain experiments, the result ends up over there at faster than the speed of light. They haven't proved that at all. It's a lot of nonsense. And the best physicists know there's a lot of nonsense that people talk about that stuff because they can't do statistics, those people. But it is conceivable that there are faster things than that, and that just like sound was a second order effect of light, there could be other levels above there which have the same result coming down. And there are beliefs in that. The theosophical folk who have a lot of these, have a lot of diagrams that get nearer to this than what the scientific people do. They reckon there's 2 levels above that. It's consistent with, I'll talk a little bit maybe somewhere along the way here about what the Buddha taught. But the Buddha supposedly taught devas on other worlds. He knew there was existence. He talked about other star systems with worlds, and we now know that the nearest other star is 4 light years away. But he gave them discourses, and they asked him questions, and he answered it. Now, it didn't say he waited 4 years to 8 years to answer and things like that. So it would have to be at some higher speed, and that it may be that 2 levels up there is mind, and that you can do that in a matter of a couple of seconds. So I don't know. It's speculation. But if you don't speculate, but don't go beyond what we know.
Sure. You've labeled these with the classical elements. Have you found any correspondence in terms of how these classical elements were understood by the ancients?
I don't know. In theosophy, they talk about inner and outer octaves, and I suspect that they were trying to describe this thing I've got here with these huge intervals. And then within each one, you've got lots of, got all those ratios that we're familiar with the harmonics. So I see that there.
So it's an interesting speculation, but you haven't you haven't really delved into it.
You would have to get someone to translate the old books, because, for example, Fred Hoyle, when he was looking at stuff relating to Stonehenge, he found that that there were mentions of stuff that could be brought forward. And who was the other one? The ones that did, the guy that did was looking for planetary influences on things, and he found, I keep forgetting names.
It'll come back to you, I'm sure.
Him and his wife did a book.
Was it Schwaller de Lubitsch?
No, it was called the Mars effect or the Jupiter effect or something.
Okay.
Anyway, someone will put it in the comments for me.
All right.
He went back and looked at got people to translate the ancient documents, and because he discovered that what happens is that the position of the planet at the moment of birth, right, tends to be the horizon or 45 degrees or 90 or there or there. Those were the locations and the planets were the correct correspondence. So Mars went in with generals and stuff like that. Jupiter went with politicians, and Saturn went with scientists and things to do with time. It's some control of time. Those traditional things were there, but it was nothing to do with the house they were in or that sort of thing with the alignments of the planets. It was purely where they were relative to the horizon of the Earth at the moment of birth, and he got a very strong correlation. He decided to do it by using. He had something like he did samples of like 30,000 and 40,000 of these different ones, and he decided if it's going to show up, it should show up in the most famous people in each category. So he made a database of those, and sure enough, it showed up really well those, but the traditional things didn't show up at all. I'm told that some group of scientists decided they'd repeat this thing to prove him wrong, and they gathered a whole lot of data, new data, and they did an analysis, but they never came out with their report. And eventually one of the scientists broke rank and said, yes, it confirmed what he said, so they don't want to publish it. So there's stuff going on there. And we could perhaps, if we have time, look at some of the mechanisms by which that stuff could go on. But sure. I found other meanings to the earth, water, air, fire. When I did Vipassana meditation, which is the teaching of the Buddha for how to come out of suffering, that's been passed down, and like the guy that was a few generations ago, he explained what earth, water, air, and fire meant in the 1800s. Now, his explanation is that earth is solidity, momentum, right? Water is cohesion, tensile. Air is expansion. Fire is vibration. Now, those four things, if you put them together and work out how that works, you end up with Maxwell's equations. Right, this guy was telling this stuff about what the Buddha did about the same time, similar time to what Maxwell was coming up with his equations. So those can be. That's another way of looking at those four classical elements to give you the workings of the universe. I believe Maxwell's equations are very fundamental, and that they've actually gone to other things where to quantize light is a mistake. Maxwell's equations are right.
Okay.
Yep. So now what I've done is I put those two together, the one thing that shows you all the scales of structure in the universe and the velocities. Now, I've drawn a triangular thing there because if you go to different velocities, then to travel the same distance will take you a longer time, or in the same time, you'll travel a shorter distance. So distance, you see these arrows on the left, the distance one running up diagonally to the left, those lines are equal distances apart, 3, 4, 5, 6, 0 ratio. And the periods going down to the left are again equal 3, 4, 5, 6, 0 ratios. So when we had the things in light years, like the stars are 4 light years, the period of the star wave will be that, but we can run that down, the 4 light year one running down that way, or we can run it the other way if we're trying to do that distance.
So these points here at the top are lining up with these spaced lines here.
Yes, that's right. Yeah.
Mm-hmm. Okay.
So in the next one, I've thrown an example in. So if we take Jupiter, it's at 5 astronomical units from the sun, which is a planetary spacing, right? And it travels around the sun in 11.86 years. Now, 11.86 light years is a star spacing, right? So we're coming from that point there, below the stars. We're running down to the right because it's a period. And from the other one, from the 5 astronomical units, we're running down to the left because that's a distance. And the two will meet there on the sound wave because Jupiter's traveling at sound speed around the sun. In fact, all the inner planets, we did that before, are traveling at multiples of 12, very close to 12 kilometers per second multiples. And that's a typical speed of sound that we found. So that's showing how we're to read this thing. So why it's a universe-wide web. The important thing is, if we have the same wavelength, two waves can interact, right? Because they're vibrating in the same place, the nodes are in the same place. If we have the same period, they can interact because they're coming around their cycles at the same time. So you can get interactions by either the wavelength or the period, and that's why this grid forms.
Fascinating.
And so it's not just one point there. So in the next one, I've just labeled them with the frequencies and the periods.
Did I skip one? No, okay. All right.
Yeah, it's the same thing. It's just I put a few more numbers in there and a bit of stuff. So it gives us if people want to check up what's something, if they find a cycle of 8 hertz, they can say, oh yeah, that's a moon distance one. And it's an atom spacing at the speed of light, right? Is that right? No, I haven't got that right.
So here's
no,
the moons, right?
That's only running that way. So those are cycle periods only. The green ones go that way, the red ones go that way. Yeah. And then the next one, I've put a little bit more detail around those. Try not to put them all in at once because otherwise it gets a bit messy. So showing that there's multiple, we know that for example, in the stellar spacings, that we get 11.86 light years, 8.89, 5.93, 4.45, all those light year waves I found in the distance of the nearby stars and some other ones. And those periods are all found by Dewey in common cycles on Earth. If we run down there from the planets, we've got 11.86 years. And if we run down there from the stars, we meet. But there's multiple in each. So there's multiple different things happening around there. A lot of detail around there is why there's not only one value.
This is the universal wide web here, universe wide web.
Yeah, I think so. That's the best name I could come up with. Someone might come up with a better one.
Yep. It's a good brand.
Yeah.
So you believe this explains the structures that we see throughout the universe?
Yeah, well, the structures were already explained by the waves, but this explains the interactions between those. So we get other things happening. The interactions between them.
Okay.
Now. This is racing off. We might have done this before, I'm not sure. But this came from an article I found in a magazine. And what they did is they get human blood. Now, this is done in hundreds of laboratories, thousands of laboratories around the world. They do thousands of samples every day of human blood. They put in a centrifuge and spin it to separate out the parts for doing different blood tests. And they did notice that it does it at a different speed on different days. And somebody plotted a graph of that somewhere, and someone else did it in another place, and they said, oh, look, my graph does the same thing. So all around the world, they are finding these same fluctuations in the speed of sedimentation of blood. Someone decided, let's look a bit closer. They stuck a laser pointing on it, bouncing off it, to see how fast does blood sediment. And so the vertical scale is showing the rate at which blood is sedimenting, and then we've got 2 hours there of what happens. Now, it wiggles around a bit, does a couple of dips, then it settles down to doing very, very regular peaks. They are at 2.9 minutes, which is very typical of what I call the 3-minute cycle. So we're seeing something there. This is blood that's no longer in a human, but it's responding to the 3-minute cycle. And the 3 and 6 minute cycles I described is centered on the sun coming out through the planets. And so this is showing very clearly that even blood not in a person is responding to that wave. Of course, if it's in a person, it will respond even more. So we can understand how the sun and other bodies are influencing us all the time. We're not masters of our own destiny.
Indeed.
And that was one I did. I might have shown that before as well, not sure, but we're all forming towards a general sort of feeling about this thing. This one I stuck a microphone under my thigh and just recorded what was happening. And you can see the very fastest cycle there. I've labeled it nerve with just a little tiny step there showing those are nerve impulses happening around the body. And that's about 8 cycles per second. Okay. Then I've shown the heart one, and you can see the regular little bursts at that interval is the heart beating. And then the bigger spacing there, which is that you can see an envelope of those, is the breath. So you can see 3 of the main body waves happening over a period of time there throughout the body. Now, so those things are going on all the time. There's more cycles in our body. There's much slower ones to do with digestion and that, and there's other ones. And there's multiple nerve impulses. There's multiple brain waves and that, which we can study. But that's just to give a feeling of what's going on.
Okay.
Now, my friend Mountain Man, also known as Peter Brown in Australia, was a surfer, and I went to visit him one time early in the piece for this, and he said to me, Ray, you've got to apply this to life. I said, no, life's too complicated. I'm just trying to work out the formula for the universe. And so, he wrote a very nice article about at every point in space, every different frequency is passing through it in some direction of oscillations. And like if I look out the window and I see something, if someone over there looks out through the same point in space, they see something else. So those waves are all traveling through the same point. In every direction, there's waves traveling through that point. And so he described all of that, a sort of sea of waves at every point in the universe of waves going through it. And I think that's good to have that picture. So finally, I took his advice and I started to try and apply it to life. And so the best picture of a man to use has to be Leonardo da Vinci. So let's take his man. He was showing some other proportions here, but he's got the proportions right. So we throw some waves on here. First of all, we say the height of the man is the fundamental wave. So put that in. And then the first very strong harmonic we expect is the second harmonic. So when we do that, so the green wave is a little hard to see there, but you can see it arrives right on his genitals, which is also at the height of the base of his spine. And that's a half of a person's height for a normal average person. In actual fact, people vary a little bit, and we can come back to that if I remember. And then we do it again. It's the fourth wave, and that one comes right on the heart. Now, which is next division, and you can see the red dots there, which are 12th. The next one, after dividing by 2, and by 2 again, we divide by 3, and we get the 12th. And so you can see here, lower abdomen, upper abdomen, heart, throat, just below the nose, and the top of the head. Those are at 12ths. Now, those ones there, apart from the one at the bottom of the nose, are commonly referred to as the locations of chakras. Excuse me. The one at the third eye, just above the eyebrows there, in the center of the head, that's at 1/24. The 12th one, most people don't mention that, but in Yogananda's book, he says, yes, that's chakra at the back of the head. They're all down the spine rather than at the front, but we've got the picture from the front. So those waves of the visions of 2, 4, 12, and 24 show up in the energies of the body that are the chakra system. And then go on some more. Another strong wave that comes after that is the 72nd harmonic. Now, the Buddha referred to this fathom-long body, and that's a fathom is 6 feet, so it's 72 inches. So when we divide it by the 72nd harmonic, we get inches. Now, our body's full of inches. These are the acupuncture layers, and they're basically at 1 inch intervals. Occasionally, there's one missing, so you go 2 inches instead of 1, but basically the spacing of the things are 1 inch. The vertebrae are more or less inches. Near the middle, they get a little bigger. Near the ends, they get a little smaller. Same thing with the ribs. They're at inches as well. Oh, they're connected up there, aren't they? If we look at our hand there, it's made of inches. You look at all those joints, they're more or less inches. And our face, we go from the chin to the mouth is 2 inches, to the bottom of the nose is 1, to the eyes is 2, to the eyebrows is 1, and then there's some more up there. So that we can see our bodies divided up in inches. So that's it's clear in the physical things, but it's also in the subtle energies of the body.
There's that imperial scale again.
Yeah. We're going to have to work out how to have both, aren't we? Imperial and the metric. Yeah, they both have their uses.
Yep.
And what's next? So that's just a front view showing the same thing with the acupuncture points. I'll tell a funny story here. I used to belong to this group. Well, there used to be this group that I belonged to called Friends of the Scientific and Medical Network. Now, the Scientific and Medical Network was set up in England and Europe by mainly medical people, but other scientists who felt that there was these people that I talked about before, who were the seers and the New Age ones and so on. They felt that these people had some validity and often did find out things the others didn't know. and they wanted to try and get them to meet with scientists. So they decided they had some rules which were listen respectfully to what someone says, criticize. If you criticize, it's to be on the basis of evidence and so on, not on the fact that you don't like their ideas. And they agreed the way they would operate things. And they were very good rules and nice rules that any civilized person would want to operate by. But if you ever get on the internet and say something that some of the physicists don't agree with, you will find those people do not like to obey those rules. They're rude, arrogant buggers. Now, so they had that set up. And
it seems to be the culture, you know? It seems to be the culture itself, one of competition and kind of looking smart and besting your colleagues.
Yeah. So it was very expensive to belong to that organization in Europe, and most people couldn't travel there anyway. So they set up what they called the Friends of the Scientific and Medical Network, and people gave talks on all sorts of interesting topics. I gave a couple of talks on harmonics theory and other things. And one guy was a doctor, and he'd gone into practice with an acupuncturist who died. And he ended up studying acupuncture so he could look after their clients as well. And he was doing a talk on acupuncture there. And I was one day off a Vipassana course, so my body was very sensitive, feeling sensations everywhere. And he started doing something. Somebody stuck a needle in the guy's foot and one in his wrist, I think. And he was trying to get them to intersect somewhere in his brain. And he was going to do something. But when he did it, I got a bunch of strong vibrations. I need to go up a bit in my chest there as a vertical line, like a bunch of those. And when he was at a pause and talking, I said, "Are these points I'm showing you here related to what you're doing?" He said, "Yes, that's on the same meridian as the one I'm doing. And those are the acupuncture points you're showing." And I said, "I just got sensations on those, probably because I've just been on a Vipassana course and very sensitive to the sensations now." So they're very real. Some people say these don't exist. It's just imagination. I got a friend who had a little device. It looked like a little pen, and he could put it on your arm. He could feel around, and the thing would go when he got on an acupuncture point. It's quite clear that something's going on, you know. So people who deny the existence of them, it's a lot of they are very real.
A lot of good outcomes with acupuncture myself.
Yeah.
So, all right. So just kind of going back, summing up, right? We've got this structure as predicted by Harmonics theory. We see it at in the large scales with these intervals of 34,560, roughly. Which is the typical interval, we have to say, not the exact one. Yeah. Right. And then and we have introduced the idea of what do we call this? This kind of scale of velocities. Yeah. Right. So that was the big idea kind of introduced this time, is velocity. Yes. And this as the universe wide web. Yeah. Where, should I take out a copyright on that or a patent or something? I think you might, you can be Tim Berners-Lee of the universe instead of just the world. So, there's relationships, ratios of distance and period. And then there's also velocities, and the way those interact kind of create a lot of, what would you say, patterns or observables at these points? Yeah. Well, there's phenomena. In standard physics, light and sound are different things, and I don't think they think of continents and oceans as having wave natures or anything. But it's clear to me that all these things have a common nature, and that all of these other ones that are along the top have a common nature. They're all standing waves. We went through and showed that the presence of those standing waves, that we could find both the velocities and the distance spacings that matched each other. That shows there's a wave nature there. And since we did that, they announced that they detected gravitational waves. I'm trying to find out how to get some of that data from the gravitational waves to do a cycles analysis to see if we can actually find some waves in there that some of the known ones are. Okay. Yeah. And then we see it in the human body as well. Yeah. The sedimentation rates of blood with breath versus heart versus nerve. Well, there was one more thing I was going to say on that one, wasn't there? That if we
we've got time. Yeah, so if we consider, there's a guy named, what was his name? It might have been Wagner. It started with a W. He called them W waves. He found them in wood, in trees, about 1 meter per second wave. He found impulses traveling in trees about that speed, which is a nerve impulse speed. But as I showed you, it's also a heat impulse speed. So that he found those traveling around, and he considered it for some other things. So he looked at it in terms of the radius of the sun and the speed. It worked out that a wave in the sun would actually give you the solar cycle at that speed. So maybe it's got nerve impulses. Anyway, it's got heat impulses for sure. So that's one. But then if we start to apply that 1 meter per second to the human body, what happens? A wave that goes from the top of our head to our feet and back. Let's say a person's got a height of 1.75 meters. Makes it easy. It'll then take 3.5 seconds to go there and back. Or you can call that just under 0.3 hertz. That is the delta wave, that delta brainwave, right? So that shows, that's the meaning of the delta brainwave, in my opinion, a wave that goes from head to head. It's a standing wave in our body.
Wow.
Then when we look at the other brainwaves, we'll find they correspond to the dimensions of the head, to the brain, to half the brain, and so on. And all those come out there.
I love it.
Our chest. If you go take a circle around a person's chest, then it'll go around in about a second, that wave. And that's our heart rate, about 1 beat per second, 60 beats per minute, right? So that one's there. If you take a human eyeball and work it out as a standing wave in an eyeball doing that, then that gives you about, I think, 23 cycles per second, which is about the frame rate at which we can detect things with our eyes. So all these things show up that the dimensions of the body and that one impulse speed show us the sort of waves that are going on. I think it's an area for more research for people to look for these waves, for these other ones, to see these connections.
Very interesting.
But everything is much more connected. I mean, people say everything is connected, but they don't really practice it, I don't think. Yeah, we better have this one, what Dewey said.
Would you like
to
read it?
Do you want me to read this?
Yeah.
This was published in 1947 by Edward Dewey and Edwin Dakin, The Science of Prediction. He says, we now have hundreds of well-authenticated cycles and thousands of allegations of other cycles to be restudied and re-evaluated. Periods group at certain definite wavelengths. Things that have the same wavelengths turn at about the same time. Cycles keep on coming true after discovery, and when distorted, return to their former timing. Cycles go back continuously for hundreds and thousands of years. In fact, they have left their imprint on rock strata that are millions of years old. It's interesting, isn't it? This is 1947, and yet his paper on the case for cycles from 1967, which was done there, and yet this is basically telling you a lot of the stuff that's in that, isn't it? He was already aware of that in 1947. Yeah. A new science is taking form beneath our hands and eyes. New vistas invite exploration almost daily. Things are moving so fast and so favorably that it is difficult to keep pace with them. We are not there yet, but things have been pretty well rough-hewn, and except for cause, the discovery of which is merely a matter of time, our mosaic is fairly well complete. Yeah, well, as he described it there, it is, isn't it? But much remains to be done, and I have no desire to join Tycho Brahe until the great cycle mystery has been resolved. The reference to Tycho Brahe is Tycho measured the positions of the planets far more accurately than anyone had done before. Actually, possibly not. Some of the ancient Indians probably did it that accurate. But he had very good measurements very regularly, and he was accurate to about 1 minute of arc, which is, with naked eye observations, about as best you can hope. And he had all these measurements, and he let Kepler look at some of them to try and do his calculations. And Kepler knew that he was holding back the observations of Mars, and Kepler knew Mars was a special case. And the reason is Mars has got a quite elliptical orbit and is quite close to the Earth, so it goes very far and everything. So he kept on at Tycho to give him his Mars observations, and eventually he managed to get them out of him. Tycho was a character. He only had one eye. I think he lost it in I probably get the wrong story. He might have lost it in a duel. I'm not sure. So when he's talking about joining Tycho Brahe, he's referring to the fact that Kepler used Tycho's observations to work out the planetary orbits for an ellipsis. And this was a huge step forward in our understanding, because then from that, we had Newton, who could work out the force of gravity as applied to planets would make elliptical orbits. So it was a very important point in the development of science. However, my desires count for little in the pattern of God, and it is not destined for me to carry this quest through to final victory. It is my earnest prayer that somewhere there is another Kepler. So I'm hoping I'm the Kepler. I'm not supposed to say that. Perhaps it could be you.
So far, I'd say.
Perhaps it will be you who someday will run his finger down our royal figures in a computation formed by Dewey in all those years and say, here is the answer. Well, I did run my finger down them, and there was a lot of answers. The solution of our mystery is near at hand, requiring only much hard work and time. Time. I have lived with that word for the better part of my life. I have measured time. I've cut time into chunks. I've turned time back to explore pulsations long ago silenced. I've projected time into the future till I cannot hold it back, and there is so much yet to be accomplished. Yeah, it's a really heartfelt thing, isn't it? And here we are, all these years later, where we're trying to get. We haven't even really got everything that Dewey did back to where it was, have we?
No, I wonder what your thoughts are on why Dewey's work has been so neglected. I mean, there's all this cycles talk going on today. You've got Ray Dalio, you've got Neil Howe, you've got Peter Turchin, all these popular books, bestsellers. Everybody's talking about cycles, and nobody ever even mentions Dewey.
No, the hard science guys don't want to know. I've approached many of them with the Harmonics Theory. I've approached many physicists, cosmologists, astronomers. You get a much better reception amongst the health people, and geology. It went quite well. When I talked in Russia, Professor Afanasiev, he came and gave me his book, which had all his measurements of cycles, which I still want to get translated fully into English, but I understand enough of it. He shook my hand and thrust it in my hand, and quite clearly there was a meeting there in a very short space of time between his observations, which are as good as Dewey's, but in this one specialized field, and my theoretical one. So, but I talked to guys at Princeton University, one of the top astronomers. And he was a couple of times I said something that made him sit back a bit and think. But he was busy on trying to prepare a talk that he had and didn't give me the attention that I really wanted. And the other ones, I've had a couple of physicists do long chats with me about things and acknowledge something. But they decided, they both said, I'm just going to carry on with what I'm doing. It's interesting what you do. It is science. But it's not what I choose to do. So I think I asked some of the Russians in the 90s, why is there this difference? And the ones in Russia said, it's the tenure system. He said, we didn't have that, and people can study more stuff without the risk of getting kicked out. But in America, the tenure system means you've got to stay on the straight and narrow, because there's a lot of people trying to guard the rules of it all. And I see this in every area of human knowledge. And this is a plea to all those people. Stop doing that. In the tenure system, he said, we're changing that in Russia, so it'll be like that in Russia from there on as well. So it probably is now. But I have noticed that a number of, in the West, a number of clever people, when they get to they become Professor Emeritus, they no longer have to publish or perish. They can say what they want. And a lot of them have got stuff that they stored up for decades, and they come out with it then. They may not get accepted, but they do come out with what they really think's going on. So I think that's an interesting area for someone. I hope I'm mentioning a lot of areas that are interesting for people to take up in the future for these things.
Wonderful. Before we end, Ray, I just wanted to ask you a question. So this week I had a chance to talk to Neil Howe, who wrote The Fourth Turning, and now The Fourth Turning is here. Are you familiar with his work at all?
I've heard of it, and I've been told about it by someone else, and I may or may not have ordered it. It hasn't got here yet.
The basic idea is that there are these generational cycles, right?
Yeah.
Every 20 years or so, 20 to 25 years, you get kind of these generations, right? But there's a 4-generation cycle where you have, and I don't think I can name them exactly, but it's basically a repeating pattern of 4 generations. And the idea is that each generation is kind of reacting to the generation before it, and reacting in kind of an opposite way, right? So you had, coming out of World War II in the United States, you had a lot of cohesion and unity and structure in the culture and in the generation, right? And then after that, the children of that generation then became adults, and they didn't want to be like their parents. So they rebelled against that structure, and you had
we became the hippies,
the 60s and the 70s, right? And then you have, after that, then there's this kind of what's called the nomad generation, who is kind of, they were kind of ignored by the self-discovery, people in the 60s and 70s, and then finally out of that you have the kind of crisis generation, that it all, kind of disorder prevails, and then a new order arises out of that, and the cycle starts over again. Okay. So that's the idea. And one of the things that he said in his new book is that this cyclical generational pattern didn't start happening until basically, like Descartes and the Renaissance, et cetera. It wasn't until we saw this idea of progress really start to dominate in the West, right? This kind of linear idea of progress, that's when this saeculum, he calls it, 4 generations, 80 to 100 years cycle, began, right? And I was fascinated by that, because I thought, why all of a sudden did this pattern of cycles start happening, right? When we were trying to get away from cycles, right? So the idea of linear progress and getting away from cycles, right? Because before our wonderful, world of linear progress, we had more of a cyclical view of each generation. Every generation kind of did the same thing, right? We had archetypes that we aspired to, but each generation kind of repeated the former generation, as opposed to having to differentiate themselves from the former generation. So I just thought that was interesting. And it made me think, and this is what I'm wondering, just your thoughts on, that when you try to suppress cycles, right, that's when they actually ultimately exert an even more controlling force on us. People don't want to talk about cycles because, this idea that we're not masters of our own destiny, right, is distasteful to us. But
well, the Russians, it was more distasteful. They got sent to Siberia because you weren't allowed to say everything. Everything had to be the struggle of the working class. So it was really bad there.
Right. Isn't it just fascinating, though, how the more we suppress cycles and a knowledge of cycles and
the more they come out
of cycles, the stronger that they manifest.
I've got another example like that, and I often think about it, because often the gut reaction of people to try and make a change is the exact opposite to what works. So, for example, suppose you've got a spaceship orbiting around the Earth, and you want it to go a little bit slower. So you think, okay, I'll point the rocket out the front and fire it for a while, and that will make me go slower. Actually, it won't. It'll make you go faster. If you want to go slower, you point it out the back and fire it, and that will gradually lift you into a higher orbit, and you'll be going slower. So that's one example where the exact opposite to the obvious thing works. And I see this in a lot of social and political and things that people do things at the exact opposite. For example, in New Zealand, we have some big fluctuations in our economy due to allowing too big a burst of immigration. And the result of that is the price of housing is very strongly affected by immigration. And so they think, okay, we've not got enough houses. We need to get some more labor to build them. So they bring some more people in. And the result of bringing more people is you're now even further behind on the houses and all the other infrastructure. So these things have big effects. And I've done work on that, and I can't convince anyone of anything. I found one or two economists that understand that and have written stuff about that. But on the whole, it's totally not understood. Yeah.
Interesting. All right. Well, Ray, it's been fantastic. I have a request too that, we've gotten a lot of feedback that we don't talk about markets enough in this series. And I think we should do one more episode and look at how this theory pertains to financial markets. What do you say?
Yeah. I want to do the stock market. And there's one of the interesting things is, a couple of the cycles, the 17-week cycle, Dewey studied it right through hundreds of years, and also the 40-month cycle studied for long periods. And I've done studies of both of those. And in both cases, you find there are modulations on them. So the cycles of the cycles. Now, I'm not certain. There's two ways of looking at things. One is you've got a cycle and it's modulated. It's like we use FM for radio, not just AM. And we modulate the frequency. But the other way is that there's actually multiple cycles near each other that interact to cause the modulations. And I think both ways are valid. But to say which is actually true, because the modulations that do occur, the periods of the modulation cycles are other harmonically related cycles. That indicates it is an interaction like that. So I'd like to go on that area because everybody can do the cycles and project them ahead. Yeah. If I'm to be any use, I've got to come up with something extra to that, and that is the modulations.
That's fascinating. It actually came up in a meeting we had this week in the master working group. We were looking at a 56 period cycle and a 51 period cycle, which were both kind of on either side of the 53. And when you looked at a composite cycle of them, you got these there were periods when when the module, when it was really spread out, and then it came together in the middle.
Yeah, that's right. Yeah.
So great. Look forward to it. All right.
Okay. Well, thanks very much, Richard. See you in a
couple of weeks. Good day.